G'day chemistry students, in this video we are covering dot points 7.4.3 and 5. Our focus is going to be on combustion of alcohols and in particular measuring the molar enthalpy of those reactions. So we'll be doing a revisit of calorimetry. The purpose of this video is just to sort of set up what we're doing, what are some of the fundamental concepts going to be when we get down to doing our practical and calculations. Let's get into it. So first off, quick revision of what calorimetry is. Essentially, we are undertaking a chemical reaction. In this example on the left, the chemical reaction is the burning of some sort of flammable substance. We capture the release of energy from that reaction into water or some other substance. We measure the temperature change of that absorbing substance and are then able to calculate first how much energy went into the absorbing substance and then determine how much was released. We can then also apply a molar calculation to those results as well. Now, we've talked about the concept before of using a bomb calorimeter, essentially by conducting a reaction inside a heavily insulated container, as well as ensuring that the reaction vessel is completely surrounded by your absorbing material, such as water. You ensure that no energy is lost from the surroundings or any other substances that might be present. So, for example, the glass that is in a beaker, possibly a tripod and gauze mat, etc. We can have other calorimetry setups like the one on the right, in which the reaction and the absorbing material is in the same location. Keeping in mind, for a setup like this, we can have endothermic reactions take place as well, in which the absorbing material will actually, instead of taking up energy, will end up providing energy for the reaction to occur, actually meaning that that material, the solvent, in this case water, would indeed cool down. In our experiments for the combustion of alcohol, we're going to be using a spirit burner setup similar to this one. When completing calculations, first thing we need to do is figure out the Q of water, the amount of energy that the water has been able to absorb from the combustion reaction. For that, we need to know the mass of the water, its heat capacity, as well as its change in temperature. Noting as well that the heat capacity of water is in your data sheet too. If you are ever going to have to do any calorimetry calculations that don't involve water as the absorbing material, then you will be given the specific heat capacity for that particular material in the question. Something else to keep in mind is we have to assume that Q and delta H are negatives of each other. So we have to assume that if Q is negative, that it is losing energy, then in the reaction, delta H is positive. Energy has been gained for the reaction to proceed. That would be an endothermic process. If Q is positive here, then what that means is delta H would be negative. An exothermic process would be happening as energy would be being released from the system. Now, if we are finding the enthalpy change for a particular reaction, this is a molar measurement. So in the case of combustion reactions, that would mean heat released from the system per mole of fuel consumed. So negative Q would be a negative of the energy absorbed by the reaction, meaning the heat released, and N would be the number of moles of alcohol which has been burnt. We're keeping in mind as well that when completing these calculations, we are assuming that the magnitude or the size of the energy absorbed or released by the water is exactly the same as the energy which is absorbed by or released by the chemical reaction. However, we've talked about before, even in the previous slide, that there are potential sources of error that can be mitigated using the right equipment, but there are potential sources of error which may mean that the energy that's being released by the alcohol is not going to be the same as the energy which is absorbed by the water in this experiment. So in the previous term, we conducted some calorimetry experiments for neutralization reactions. So just wanted to highlight some of the differences again between neutralization and combustion calculations when doing enthalpy. In both experiments, we are determining a molar enthalpy. What that means is that we're finding out the amount of energy which is released or absorbed by the reaction per mole. But what's different about the two reactions is what that is a per mole of, essentially. So for molar heat of combustion, we're looking at energy changes per mole of fuel consumed. That then enables us to compare the different fuels that we react with. On the flip side, when completing a neutralization reaction, in every reaction we have water as a product, meaning that we can compare neutralization reactions per mole of water produced. So that is the main difference between the two. This is something that we always need to keep in mind. Molar ratios always come into play with these kinds of reactions, and our molar measurements for enthalpy are different for both reactions. So please be mindful of that when completing these calculations. Now for this video, I'm not going to be completing a calculation explicitly. We've done lots of calculations in this course before. If you need a refresher on what some of these calculations look like, please refer to the module 4 videos. Thank you very much, everyone. In the next video, what we're going to be covering are organic fuels. This dot point particularly focuses on the viability of some of these fuels in terms of their use and production, as well as their environmental impact. So I'm going to be sort of setting the scene and bringing up a lot of talking points that need to be considered to be able to make a judgment on organic fuels themselves. But until then, have a good one.